Okay, we're almost done with looking at the real numbers, and before we start constructing them, this is just very short. One other thing that I want to look at is what is a decimal? And then the next video, we're going to show that every positive real number has a real root. And then we'll move on to actually constructing the real numbers. So I just want to look quickly at, with what we've looked at so far, how we can understand what a decimal number even is. So let x be a positive real number. Let n0 be the largest, integer, such that n0 is less than or equal to x. So this is the reverse Archimedean property again. Normally we can find an integer that's larger than x, but one of the corollaries that I showed was that then you can also find an n that's less than x. And what we were just showing earlier is that there's also then a largest one that's less than x, because then any one bigger than that would be on the other side of x. So now, assuming that we've chosen n0, n1, n2, up to nk minus 1. So we're just giving, this is another form of the induction principle in a way, that we're just going to assume that you've already chosen some number of these. So now we're going to look at the next one in line. So having chosen these already, let nk be the largest integer. Such that n0 plus n1 over 10 plus n2 over 10 squared plus nk over 10 to the k is less than or equal to x. And let E be the set of numbers for k equals 0, 1, 2. Let me just finish saying this. Then x equals sup e. So what we're doing here is we've already chosen everything up to nk, up to k. So then let nk be the largest one such that this sum is still less than or equal to k, so or less than or equal to x. So we chose each one of them in that way. We started with n0, that's the largest integer that's less than or equal to x. Then we pick another integer such that that number divided by 10 plus the first one is as large as possible, less than x, without going over. Then we do the same thing for n2 over 100 and so on until we found the last one, the nk, that still makes this sum less than or equal to x. Then if we let E be a set that is each one of these numbers, so the set would be just n0 and then n0 plus n1 over 10, then n0 plus n1 over 10 plus n2, and so on. So each one of these partial sums is an element of E. Then x is the supremum of that set. So if you think about the way we think about supremums, what this is saying is we have a set that is getting closer and closer to x without ever going over x. So x is here somewhere. And the elements of E are n0, and then maybe n0 plus n1 over 10, and so on. Each one is getting closer and closer. And you can keep doing it arbitrarily. You can go as high as you want. They're always going to get closer and closer to x without ever going over. So that x is the supremum of E. So then what we're saying, the decimal expansion of x is, then you just write down these numbers in a particular way that we're all used to. N0, decimal, N1, N2, and so on. This is the decimal expansion of x. So what we have here is
failure to communicate.
We're looking at how do we write x as a decimal number. And this is how we do it. We have this set that gets closer and closer to x without going over, so that x is the supremum of all of these partial sums put together. And then, given this set, the decimal expansion of x then is just these numbers written together like this. Conversely, if you are given a decimal number, then that number represents some set of numbers, e. That number is bounded above because at each point, each one of these numbers is just the next fraction, never going over. There's some number that is just greater than however far you've gone with the fraction. And that set has a supremum, and this number is the decimal expansion of that supremum. So it goes either way. If you start with the decimal, then this decimal represents the supremum of the set that you can extract from the decimal. Or, given the number, you can create a decimal by making a set of this form, and the set of that form will have x as the supremum of that number. That's what decimals are. So what I love about higher math is the next thing that Rudin says here is that since we shall never use decimals, we do not enter into a detailed discussion. It's one of the coolest things about math, that real math, meaning higher math, has nothing to do with numbers. It has nothing to do with arithmetic, nothing to do with, measuring things or accuracy or anything like that. So everything that we're doing from now on, it's all conceptual. It has nothing to do with actual numbers. So, all right, next time we will look at roots of numbers, and then we will construct this set that we've been talking about.
What we got here is a failure to communicate.
Okay, here is the link to the first video in this chapter. Here is the link to the previous video. Here is the link to the next video. And click here to subscribe, and please join me on Patreon. The link to that is below in the description. Thank you.